Alright, for this last lesson for the polynomial operations, we're going to do some problem solving, which is a core tenet of what you're going to be doing throughout the rest of your high school math. So the area of the given figure can be written as a trinomial in the form of ax squared plus bx plus c, and it wants us to figure out what those values are, a, b, and c. Well, the first thing is I'm going to break up this two-dimensional shape into more simplistic shapes that we know. So what I'm going to do is I'm going to split this up here so that I can have my rectangle in here. Now for the other part, you can choose which method you want to do this. You can either leave it as a trapezoid, if you know what the area of a trapezoid is, or if you'd prefer, you can split up the trapezoid into a rectangle and a triangle. There isn't a wrong answer here. I have some missing side lengths based on what I see here. I don't know what this side length is. I don't know what this side length is. And I don't know what this side length is, which happens to be the same as this side length. So the first thing I need to do is find what these missing side lengths are. If I'm finding the missing side lengths, then we've experienced this before. I'm going to figure out what it is based on the information that's given to me here. I know that this side length, let's call this side length m. I know that m is the difference between this whole length here and this shorter length here. So I could say that m is equal to 3x plus 6 minus x plus 4. If I take the 3x and I take away an x, I'm left with 2 x's. And if I take the 6 minus 4, I'm left with 2. Now, when I get up to the top here, like I said, if I know how to do the area of a trapezoid, I can make this a lot easier on myself. I can take the area of the trapezoid all throughout here, and I just need to solve for what this one side length is. If you don't know what the area of the trapezoid is, then you can figure out what this side length is because it matches this side length, and this side length matches this side length. So I can say that this, let's call it, I don't know, n, is equal to x plus 4. And the last part that I would need to solve is going to be this part. Let's call it O. And this side, O, is going to be the entire length along here minus this and minus this. Which means that side length O is going to equal the 4x plus 9 minus 2x plus 3 and minus x plus 4. The 4x minus 2x minus another x leaves me with just an x. And the 9 minus 3 minus 4 leaves me with a 2. Now, I can say that the full area is going to be the large rectangle plus a small rectangle plus the triangle. So my area is going to equal 3x plus 6 times 2x plus 3 plus 2x plus 2 times x plus 4 plus, here's a tricky one, the 2x plus 2 times x plus 2 divided by 2 for that triangle. I can FOIL this out, and I'm going to get the 3x and 2x gives me 6x squared. 3x and 3 is 9x's. 6 and 2x is 12x's, and 6 and 3 is 18. For the second set, I get 2x and x is 2x squared, 2x and 4 is 8x's, 2 and x is 2x's, and 2 and 4 is going to give me 8. For the last one, if I multiply out just the top, I'm going to wind up with 2x squared, 4x, 2x, and 4, all divided by 2. And I can divide every single one of these terms by the denominator of 2. So really what I have is 6x squared plus 9x plus 12x plus 18 plus 2x squared plus 8x plus 2x plus 8 plus 1x squared now plus 2x's plus x plus 2 when I've divided everything by 2. And I'm going to combine all my x squareds. I'm going to combine my x's and I'm going to combine my constants. When I combine all of these things together, it simplifies to 9x squareds, 34x's, and 28, which means that given this problem, a is equal to 9, b is equal to 34, and c is equal to 28. Now, we have the simplified formula for what the area is once we multiplied everything out and simplified it. When it says calculate the area if x is equal to 2.5, all I'm doing is I'm just replacing all the x's with bracket 2.5. And if you use the brackets properly on your calculator, you can put all of this in one go, and you wind up with 169.25 units squared. For example 2, a rectangular garden with the length of 8 minus 3a meters and a plus 8 meters contains 3 square flower beds, each with a side length of 2a plus 5 meters. Everything else is grass. Draw a diagram to illustrate this information. Well, first thing is I need to draw a rectangle. Then I'm going to draw 3 square flower beds inside and indicate that all the side lengths inside there are the same. I have one side of the rectangle is a plus 8 meters. One side is 8 minus 3a meters. And all of the sides of the squares are 2a plus 5 meters. And if I want to be more specific, everything around those flower beds is grass. If I wanted to write a simplified equation for just the area of the grass, then that's going to be the area of the large rectangle, a plus 8 times 8 minus 3a, and then I'm taking away from that the 3 squares, which all have an area of 2a plus 5 squared. When I expand this out, I get 8a's plus 64 minus 3a squareds minus 24a's minus 3. Don't forget to square out this binomial. First term squared, first term times second term, or 2 times 2a times 5 times 2, and the last term squared. And then I'm going to distribute that negative 3 into my product. Negative 12a squareds minus 60a's minus 75. Combine the like terms. I got the a's, I have the constants, and I have the a squareds. And when I combine them, I wind up with negative 15a squareds, negative 76a's, and negative 11 meters squared. If I want the area of the grass, if a is equal to negative 1.5, I'm doing the same thing that I did last time. The area is equal to negative 15 bracket negative 1.5 squared minus 76 bracket negative 1.5 minus 11, and the area that I get when I plug this all into my calculator is 69.25 meters squared.